Hello, this is Dr. Satish Singhal, PhD, Professor of Computer Science, El Camino College, Torrance, California. We're going to talk about user-defined functions in C. This part 1 will apply equally well to C++ language, uh, although part 2 and others may be a little different. We plan to do at least maybe 4 parts. I'm not sure right now. This part 1 will be done only in PowerPoint. We lay down the foundation, and then part 2 will do some compiler use and coding. Okay, software is getting big every day. Consider the lines of code in following pieces of software. Next slide. Typical Hello World program could have 1 to 10 lines of code. Implementation of stack and queue data structure in C++ standard template library may have 10 to 100 lines of code. El Camino College CS1 and CS2 projects may have 100 to 2000 lines of code. Capstone project in CS senior year may have 2000 to 10,000 lines of code. Linux command line utilities might have code lines from 10,000 to 100,000. Linux G++ compiler may have code line from 100,000 to a million. Firefox browser may have code lines from 1 million to 10 million. Windows 2000 kernel may have code lines for 10 million to 100 million. Debian Linux operating system may have code lines from 100 million to a billion, and Human Genome has code lines up to 3.3 trillion. Okay, so can you see how big software is getting with time? So it is not possible to write all code in main function. It is not possible to write and maintain millions of lines of code when programming is done only using main function. Thus today, even reasonable sized software products are broken down in main function and user-defined functions. And then these many functions are integrated together to form composite software. The software you use today is not just one unit. Rather, like a car, it is integration of many functions. Each function is developed and tested more or less independently. That kind of testing is called unit testing. And then once all the functions are put together to form the software, then another testing is done called integration testing. Now we want to develop and we want to discuss following subtopics. We want to fully understand technology of functions, and we break down the topics of user-defined function in following subtopics. One is value returning versus void functions, parameter passing mechanism, value versus address passing through pointers. We will not discuss this one too much in this video. This will be done in the future video. Function prototype. This also will not be done in this video. This will be done in, and code reuse also. And this will be done in future video also. But these are the subtopics. In rest of this video, we'll focus mostly on this part here. So we'll roam through many documents and codes, not necessarily linearly, to go through all the topics, subtopics in the previous slide. At times we will tell you something which will only be seed for thought, but will become clear later when we have given the whole example for an initial concept. Let us begin our journey through learning two types of functions, and we will code each type after that. In this one, we'll just show you an example here. Next video, example in the compiler. So there are two types of functions, value returning versus void function. You have used this one, my students have used this in assignment on computational compound interest when they called power function called POW. These two kind of functions are value returning. This one always returns a single value to its caller and call from within an expression. The call is on the right hand side, value it returns is on the left hand side. Return value is either directly stored in the parameter on the left hand side, or it might be multiplied by some other value, or some other arithmetical operations might be done on it. Void function never returns a value to its caller, and it's called as a standalone separate statement. So this is just a program. Call to void function, just a program statement. There's no assignment operator in the call of void function. So in the function call itself, you'll see when value returning function is called, there is a assignment operator. This one does not have an assignment operator. And the function call mechanism is like this. One function call another by using the name of the called function next to a parenthesis, and this parenthesis includes argument list, optional argument list. Actually, arguments are a way for functions to communicate with each other. Caller function supplies the argument, called function uses the argument. And if there's more than one argument, they're comma separated. We'll see examples of that very soon. And what happens is that function call temporarily transfers the control from calling function to the called function and executes the algorithm in the called function. Okay, so in value returning function, what happens is, you saw in assignment 2 when you used POW function in math.h library. When POW function was used to compute compound interest, following syntax was used. Money equal to initial deposit into POW. 1 plus R is the interest rate at which deposit is made in fraction. Q is the compounding frequency, number of times compounding done per year. N is the number of year left in the deposit. Q is again compound frequency per year. So when you executed this, when this function was called, then control is transferred to this function, this piece of software inside math.h library. And using these arguments, POW or power function executes an algorithm, computes the required computation, and value return is then multiplied by deposit, and then this composite value is stored inside the money. Thus, POW that you used here is a value returning function. Okay? And typical value returning function looks like below. There will be data type other than void here, then a function name as POW, and there's an argument list, argument 1, argument 2, argument 3. In function call, which we did here, argument list contained the values that user would like to pass to the function. But this line, which is called a header, and again we'll see a code example in a minute, argument 1 will be data type and its formal name, placeholder name, data type, placeholder name. That's how they are done. And then value to be returned is computed using proper algorithm that uses all these arguments. May not use all of them, but supposed to. And then this computed value using an algorithm is returned using a return statement that is a C keyword, and that computed value is returned. Data type of this computed value should be same as this one. So this data type that is returned is same as this one. It should be a C keyword, C data type other than void. It doesn't have to be keyword. It could be int, double, float, char, pointer to any of these, or could be user-defined data type. Okay, so C keyword, data type other than void, same data type here that's being returned, and so on. Okay, that's the description, formal description. Code example is here. Let's say we write a function that cubes the value passed to it. So first word will be return type, which has to be other than void. Function name, this is user chosen name. Parameter list, so this really says that this n is int type, and this is kind of, once you have put a parameter here, this will be just like a local variable to this function. If I declare another variable, that will be local variable. This will be treated like a local variable, but it should be used, and it's being used here. Multiply n by itself 3 times, becomes a cube, and there's the return keyword. So function has header, and the body. Now this return statement may be blank, like you put a semicolon for the void function, or totally absent in the void function. But value returning has to be there. And data type of this and this should be same, which it would be. If you take an int, multiply itself 3 times, it will still be an int. Now here it says parameter list can be empty. That usually that is not the case for value returning function, but it can be. The rules don't force you to have a parameter in any function. Okay. The void function call looks like this. The keyword void, function name, and then the argument list. And code in the body causes some side effect. Printing some data is the most common side effect. The function argument arg1, arg2, etc. are used in causing the side effect. At the very least, it should be used. Function should not be passed useless parameter that have no real purpose. Okay, that's a very important thing. That's a design rule, more or less. Okay, notice there's no return statement because it's just causing some side effect. Printing data is one of the important side effect. And here we show the example. Void display math love int year. In this case, this void function is creating an output. Printf, I have loved math for years. Okay, and notice there's no return statement. Here's the one of the code example of void function. Now in part 2 of this video, we will illustrate these concepts using the compiler. See you in part 2. This is Dr. Singhal. Saying goodbye from part 1 on user-defined function.